Welcome to this introduction video of the Solar Energy Engineering MicroMasters program. My name is Arno Smets. I'm a professor at the Delft University of Technology and one of the lecturers in this MicroMasters program. In this video I will explain the structure of the program and explain the learning objectives for each of the courses. The Solar Energy Engineering MicroMasters program consists out of 5 courses. We start with PV1X, Photovoltaic Energy Conversion. In this course we will discuss the fundamental physics required to understand the operation of solar cells. We will apply this knowledge in the second course, PV2X, Photovoltaic Technologies. In this course we will discuss the properties, advantages and limitations of the different PV technologies that are produced. In the third course, PV3X, Photovoltaic Systems, we will use the solar panels and components to create a PV system. While in the fourth course, we will integrate the PV systems in microgrids. The fifth and final course consists of a comprehensive exam. Let's look at the learning objectives of each of the courses in some more detail. It starts with PV1X, for which I will be one of the lecturers for this course. I will be joined by Professor Miro Zeeman and Associate Professor René van Zwaay. PV1X is all about the conversion of light to electrical energy. You will master semiconductor physics necessary to understand solar cell performance and engineering. You will create an understanding of the light management tools that are necessary to design an optimal solar cell. After taking this course, you will understand the principles behind the potential loss mechanisms in photovoltaic devices, and you will be able to model all aspects of a working solar cell, understand the efficiency limits and the design rules. We will apply these skills in PV technologies. The instructors for this course are myself and René van Zwaay. In this course you will develop an in-depth knowledge of the various wafer-based and thin-film PV technologies. We will look into different semiconductor materials such as crystalline silicon, thin-film amorphous silicon, 2,6 materials like cadmium telluride and CIGS, 3,5 materials like gallium arsenide, and also organic PV such as dye-sensitized solar cells and perovskite materials. You will obtain an in-depth understanding of the entire crystalline silicon solar cell landscape, including cutting-edge monocrystalline based solar cells. You will also learn about the various module architectures employed for thin-film technologies such as thin-film silicon, micromorph structure and high-performance gallium arsenide solar cells. Finally, you will obtain the ability to design the concepts and fabrication processes of various photovoltaic technologies and the characterization of the module performance. In the third course of the MicroMasters program, we will use the PV technologies to design a PV system. The instructors for this course are Assistant Professor Olindo Isabella and Dr. Ravi Vasudevan. In this course, you will learn to understand and model the effects of the position of the sun and solar irradiance on PV module performance. You will create an in-depth understanding of all the components required to design a PV system, including inverters, DC-DC converters, batteries, charge controllers and cables. You will also learn about the economics of PV systems. After taking this course, you will be able to design a PV system for any scale, ranging from rural standalone systems to grid-connected residential rooftop systems and utility-scale solar power plants. In PV4X, we will integrate the PV systems in microgrids. The instructors for this course are Professor Pavel Bauer, Assistant Professor Laura Ramirez and Dr. Seyamadi Izat Kast. You will obtain an in-depth knowledge of the integration of PV in the grid at different levels and understand the motivations and challenges for the implementation of DC microgrids. After taking this course, you will be able to understand the operation of centralized, distributed and decentralized control and design various protection strategies applicable in microgrids. In the final course, you can prove that you have what it takes to be a solar energy engineer. PV5X consists of 2 comprehensive exams in which the knowledge you gained in the previous 4 courses is tested. In PV1X to PV4X, all the video content as well as numerous basic assignments and the discussion forums are available for free. By upgrading to the verified learner experience for one of the courses, you will get access to all exercises, practice, graded and exam questions, and access to the discussion forums to constructively interact with both their peers and the course staff. If you pass the exam and complete the course with a sufficient score, you will get a verified certificate of completion for that course. If you complete and successfully earn a verified certificate in all 4 courses, plus pass the comprehensive exam in PV5X, you can earn the Solar Energy Engineering MicroMasters credential. With this credential, you can apply to the Masters of Science program Sustainable Energy Technology of the Masters or the Masters of Science program Electrical Engineering at the TU Delft. You will need to go through the regular admission procedures for MSc students and meet the entry requirements for those MSc programs. If you are admitted, and you will be exempted for the courses that are equivalent to the courses that you completed in the MicroMasters program. Besides the regular content, the courses feature some additional content. Each course features a live webinar in which you students can interact live with the course team. The webinar generally includes a behind-the-scenes tour at the Delft University of Technology, an interview with a titan of industry, and an interactive discussion in which the course team treats the issues introduced by you, the students. Thanks for the interest in Solar Energy Engineering MicroMasters. I hope to see you back in one of the courses.